Hello friends, welcome viewers. Let's continue our discussion with mesosphere, the leftover part of this structure and composition of atmosphere, my dear friends. Very little to deal with mesosphere. Basically, it is the third layer of the atmosphere, spreading over the stratosphere, and it extends up to a height of 80 kilometers. In this layer, the temperature starts decreasing. In this layer, the temperature starts decreasing with increasing altitude, and reaches up to 100 degrees Celsius at the height of 80 kilometers. Very surprising, my dear friends. In mesosphere, the temperature starts decreasing with increasing altitude and reaches up to 100 degrees Celsius at the height of 80 kilometers. And as if we earlier stated in our earlier episode that meteors are the things generally found in this mesosphere. So meteors or the falling stars occur in this layer, and the upper limit of the mesosphere is known as mesophase. Of course, friends, it is not in our discipline the thermosphere as well as exosphere, but just I read out 2 or 3 lines. And regarding thermosphere, my dear friends, this layer is located between 80 and 400 kilometers above the mesophase. Thermosphere is a layer which is located between 80 kilometers and 400 kilometers in between, which is above mesophase. Friends, thermosphere contains electrically charged particles known as ions, and hence it is also known as the ionosphere, because thermosphere consists of electrically charged particles which are called as ions, and this is due to the presence of ions only. Thermosphere is called as ionosphere, and moreover, radio waves are transmitted from the earth. Generally, radio waves which are transmitted from the earth, they are reflected back to the earth. Radio waves which are transmitted from the earth are reflected back to the earth by this thermosphere, and due to this, radio broadcasting has become possible. I think it's clear, friends. It is just because of thermosphere only, this radio broadcasting. I think the satellites and all, that kind of activity is basically because of the thermosphere, and the abilities, the reflection back of these waves by thermosphere. It is because of this property only we are able to experience this broadcasting and all these kind of activities. In thermosphere, the temperature starts increasing with heights. And of course, with exosphere, The exosphere is the uppermost layer of the atmosphere, and gases are very sparse in this sphere because due to lack of gravitational force. Therefore, the density of air is very less in this exosphere. So, friends, with this, we conclude our topic, the structure and composition of atmosphere. I think we have dealt in detail with various things like the components, the structure, etc. And now let's continue our discussion with the things like lithosphere, hydrosphere, and biosphere. Friends, in continuation of our episode, we need to discuss about the hydrosphere, the lithosphere, as well as the biosphere. In dealing with the things like hydrosphere, lithosphere, and biosphere, which are the part and parcel of the carbon cycle. So, while you consider the Earth's surface and the areas which are near to it, this can better be divided into various spheres. I mean, in technically, if you put things in words, the area near the surface of the earth can be divided up into four interconnected geospheres that make up the carbon cycle. Okay, and these are nothing but the lithosphere, hydrosphere, biosphere, and the atmosphere. Of course, the atmosphere was our topic, which we have covered a lot in our earlier discussions. So, friends, the understanding of sphere, what it means. So, in this situation, the sphere means to surround or encompass. To surround or to encompass. In order to understand well about these spheres, I will explain them or I will define them. Now, lithosphere. Here, litho, it refers to rocks and minerals. It refers to rocks as well as minerals. Hydrosphere. And a hydro, friends, referring to water. Hydrosphere refers to things that are related to water and all. Then comes the biosphere. Bio generally it refers to life. Life. I mean, studying about the various kinds of life forms and all. Of course, atmosphere. We have dealt a lot with atmosphere. Of course, to sum up, atmosphere here, atmo, referring to steam and vapor. In the spelling atmosphere, my dear friends, ATMO, atmo means steam and vapor. Right. Friends, let's move on to our main topic, the lithosphere. Here, it is believed the lithosphere evolved about 4.6 billion years ago. Such a big time scale, dear friends. It is 4.6 billion years ago, where the origin of lithosphere or where the evolution of lithosphere has been taken place. Now, lithosphere refers to the solid rocky crust that covers the entire planet. Lithosphere refers to the solid rocky crust that covers the entire planet. This solid rocky crust is composed of a number of different rocks that have been grouped into three categories. And this categorization is based on how they are formed. On how they are formed. I mean, the process of formation is the criteria. Is the criteria. Now, there are three groups. There are three groups. Number one, this is metamorphic rock or metamorphic rocks. Metamorphic rocks are formed by heat and or pressure from pre-existing rocks. So friends, something dealing with rocks and all, we come across with the branch, one of the branches of the discipline geography, that is geomorphology, where we come across all these things like the types of rocks, the processes, the process of formation. I mean, many things, my dear friends, like weathering, denudation processes, process of rock formation, the types, and so on and so forth. So, in this context, metamorphic rocks are the rocks which are formed by heat and pressure from the pre-existing rocks. Next, igneous rocks. Igneous rocks, they are formed by the cooling of hot molten rock, which is also known as magma. Dear friends, the word magma, I think many of you know about this word. Magma is nothing but a molten material. Molten means it's a liquid form, which is a result of melting process. So, this igneous rock is a result of cooling process of the hot molten rock. So, magma, I think you have understood. This magma is nothing but the product or the outcome of the volcanic eruptions, that have taken place in various eras of our geological time scale. And of course, we can find in the contemporary era also, or in this existing era also. Many regions, of course, the Southern America, South America, the Africa, of course, the United States of America, to the New Zealand, and various countries of Europe, we all have the volcanoes. Some are, I mean, dormant, some are active, and of course, there is a good amount of classification based upon the types. I mean, the activity of these volcanoes, and I think we need not go in detail about the things dealing with volcanoes. We just confine ourselves to the word magma. So I think I made it clear for you what magma literally means, right? When this hot magma cools, it begins to harden. It begins to harden, meaning once it had fully cooled, it creates what is known to be an igneous rock. Next comes to the sedimentary rocks. Friends, sedimentary rocks are formed from pre-existing rocks. Again, similar to metamorphic rocks only, my dear friends. Sedimentary rocks are also formed from pre-existing rocks. When rocks erode and mix with other dirt, clay, and particles, then settle together, the mix to form a sedimentary rock. Just now I stated, my friends, geomorphology is a topic where we can come across various processes like the weathering, the denudation, etc. And of course, the formation of sedimentary rocks is very much linked to that kind of activity only. Sedimentary rock formation is linked to either the weathering process or denudation process only. Okay, sedimentary rocks are formed from pre-existing rocks when rocks erode and mix with other dirt, clay, and particles that settle. Okay, right. Now, the lithosphere, it includes a various number of different landforms such as mountains, valleys, rocks, minerals, as well as soil. So, lithosphere includes a number of landforms from mountains to the soil. Lithosphere, friends, it is constantly changing. It is never a static one. It keeps on changing. This is because due to the force, due to the forces and pressures. The lithosphere is constantly changing due to forces and pressures from sun, wind, ice, water, and chemical changes. The Earth's surface is composed into two types of lithospheres. These are known as the oceanic and the continental lithospheres. It is very simple, my dear friends. The word itself it gives an idea that the rock structures or the rocky things which are involved are making a water habitat, or particularly the rocky things that are existing in ocean. They are called as oceanic lithospheres. Whereas coming to the continental lithospheres, it means here the rocks which are present, of course, on the terrestrial habitats. Of course, on the terrestrial habitats, or the continents, the rocks that are present in the continents. Okay, the oceanic lithosphere, The oceanic lithosphere includes the uppermost layers of mantle. The oceanic lithosphere includes the uppermost layers of mantle. Friends, in one of our earlier episode, uh, I have explained about things like Earth's crust, mantle, and core. I think you remember these words. So here, the oceanic lithosphere, it includes the uppermost layers of mantle, which is topped with a thin yet heavy oceanic crust. This is where the hydrosphere and lithosphere meet. Friends, this oceanic lithosphere includes the uppermost layers of mantle, which is topped with a thin yet heavy oceanic crust. And this heavy oceanic crust is the place where the hydrosphere and lithosphere meet. The continental lithosphere. Friends, this include the uppermost layers of mantle. This include the uppermost layers of the mantle, and which is topped with a thick yet light continental crust. And this is where the atmosphere, the biosphere, and hydrosphere meet the lithosphere. I repeat once again, the continental lithosphere, it includes the uppermost layers of the mantle, and which is topped with a thick yet light continental crust. And this is where the atmosphere, the biosphere, as well as the hydrosphere meets the lithosphere. So, friends, now let's move on to the hydrosphere. The hydrosphere refers to the most important resource, which is water. The hydrosphere refers to the most important resource, which is water. The hydrosphere includes all forms of water. It includes all forms of water in the Earth's environment. The hydrosphere includes all forms of water in the Earth's environment. In the Earth's environment, the forms of water include things such as the oceans, lakes, the rivers, snow, and glaciers. The water underneath the Earth's surface, and even the water vapor that is found in the atmosphere. So, friends, we have used a number of words. Of course, things like the glaciers. Glaciers are the ice sheets. Glaciers are the ice sheets which are formed during various geological timescales. They're formed at various geological timescales, and these are the ice sheets. Of course, we need not go into detail. Friends, if you take into consideration the Permian era or things like that, there are various eras which are dominated by the presence of glaciers. Of course, the geysers also. These glaciers and geysers, they have the contrasting characters. Glaciers are things which are ice forms, whereas geysers are to do with the hot waters, etc. Of course, there are good number of examples while dealing with the geysers, like the Yosemite Valley in America, and of course you find these geysers in parts of New Zealand also. The hydrosphere is always in motion, as seen through the movement and flow of water in rivers. The hydrosphere is always in motion, as seen through the movement and flow of water in rivers, streams, and the oceans. Right. The plants and animal organisms rely on the hydrosphere for the survival as water is essential. The hydrosphere is also the home to many plants and animals. Friends, it is believed that the hydrosphere covers approximately 70% of the Earth's surface. The hydrosphere covers approximately 70% of the Earth's surface, wherein, dear friends, in my earlier episodes, we have a lot more discussion regarding the habitats. I mean, what amount or what the quantum of water that is contained on planet Earth, and what the terrestrial things we have. And in that context, we can definitely say that three parts of the Earth is occupied by the water, and the remaining one part is nothing but the surface, the Earth's surface, which is habited by the terrestrial, which is habited by the life forms, which are making Earth as a habitat. Earth as a habitat. Friends, let us move on to the another topic, that is the biosphere. While dealing with the biosphere is composed of all living organisms. The biosphere is composed of all living organisms, including plants and animals. Plants and animals. It is believed that all life forms or life exists in this biosphere. Of course, most of the living organisms are confined. They are confined to this biosphere. And of course, when taking into consideration the vertical vertical categorization. Here, you can find living organisms up to 3 meters 3 meters below the ground to 30 meters above, 30 meters and above. It is also up to 200 meters of the ocean and seas. It's also above 200 meters of the ocean and seas. Friends, the biosphere could not survive if it wasn't for the other spheres, as all organisms need water from the hydrosphere and minerals from the lithosphere and gases from the atmosphere. While we have our earlier discussion regarding the energy flow, friends, the energy flow means the essential things or the core things or the core organisms which we come across with, energy flow. And of course, in dealing with the energy flow, friends, I think I have forgotten to discuss about the splitting of phosphate bonds also. The splitting of phosphate bonds, it plays a major role. Of course, the energy flow is essential to maintain the structure of organisms by splitting of phosphate bonds. I think I never made this statement earlier. It's the most important thing. Here, the splitting of phosphate bonds, that is the core for this energy flow. The core for energy flow in any kind of ecosystem is nothing but the splitting of phosphate bonds. Friends, I think I have a lot more discussed about the hydrosphere, the lithosphere, as well as the biosphere. And in my, I think in my preceding session itself, I have concluded the structure and composition of atmosphere. And with this, I think, my dear friends, hope you enjoyed this session, and I made things very much clear for you about the atmosphere, biosphere, lithosphere, and hydrosphere. So with these things, my dear friends, I conclude my session as well as the episode, and meet you with a new topic in my next episode. Thank you. Thank you.